Okay, this video is on solving quadratic equations by factoring. And if you'll take a look at example 1 there on your notes, you'll notice that I've got this quadratic equation, but it's already been factored. So I don't actually have to do the first step that I normally would do in a solving quadratic equations type problem, because my first step is to factor my quadratic expression. Well, this quadratic expression has already been factored. They're my two factors. So I don't need to do that step. All I need to do now is my second step, which is to set each one of my factors equal to 0. So x minus 7 equals 0. X plus 3 equals 0. Now I've got two fairly simple algebraic equations to solve. And for this one, I just add 7 to both sides. That gives me x equals 7. For this one, I subtract 3 from both sides. And that gives me x equals negative 3. And I've just solved that quadratic equation. All right. Now, most types of quadratic equations are a little bit more involved, because most of them, like for example, this one right here, example number 2, which I believe is number 7 in your notes. This one, notice it hasn't been factored. I've got this quadratic equation, and here's my quadratic expression, and that quadratic expression hasn't been factored yet. So I've got to factor that first. That's my first step. So this one I recognize I don't have a greatest common factor to pull out. So I recognize that since my a coefficient here is 1, this is an easy case trinomial, so I can factor this one using the diamond method. Positive 18 goes here, positive 9 goes here, and I need two numbers that will multiply to give me positive 18 and add to give me positive 9. Well, I think 3 times 6, positive 3, positive 6, that gives me positive 18. It adds to give me 9. So there are my two numbers. Now I just need to fill those in to my factors here. So I'm going to have x plus 3 and x plus 6. And now I've got my equation looking an awful lot like example number 1. I've got two factors. They're multiplied together. They equal 0, which means either x plus 3 equals 0 or x plus 6 equals 0. And again, I've got two fairly simple algebraic equations to solve. I subtract 3 from both sides here. That gives me x equals negative 3. I subtract 6 from both sides here. And that gives me x equals negative 6. And now I've just solved that quadratic equation. Now, example number 3, which this one is, I believe, number 8 in your notes. Example number 3, this one is a little bit different than the other two, because when I look at this quadratic expression, I notice that I've got a greatest common factor. And I always want to pull out a greatest common factor if I've got one. And so let's see, I've got a factor of, looks like 3. I can pull a 3 out of each one of these terms. So let me factor out that 3. So I'm going to have 3, and that's going to leave x squared minus 11x plus, let's see, 3 and 72. What does that give me? 24. All right, so now my equation looks like this. All right, so now I recognize that this is an easy case trinomial. And so let me see if I can factor that, because I want to, when I'm solving a quadratic equation, I always want to have factors. I want to have my expression factored. So let's see, I need two numbers that multiply to give me 24 and add to give me negative 11. And let's see, that looks like maybe 3 times 8. And I think those are going to need to be negative. So negative 3 times negative 8, that gives me positive 24. Add them, it gives me negative 11. Okay, so now I've got my factored form of this expression, x minus 3, x minus 8. Now, this, I notice, I've got this in factored form, and this one actually is a little bit different than this one up here, because I've got this 3 sitting out here in front. I didn't have a greatest common factor on this one, I just have these two factors. In this expression right here, I actually have 3 factors. This is a factor. 3 is one of my factors. X minus 3 is a factor, and x minus 8 is also a factor. So I'd be tempted to say, well, I'm supposed to set each one of my factors equal to 0, right? Except I can't really set 3 equal to 0, because that just doesn't make any sense. You can't say 3 equals 0 and then solve that equation. So If you got a constant term out here, you don't set that one equal to 0. You just take these two factors here, x minus 3 equals 0, x minus 8 equals 0, and then I solve each of those equations, and I get x equals 3 and x equals 8. And I'm done.